So is my screen visible to you? Yeah, okay. So in the last lecture, we saw the introduction. We will be studying numerical methods, numerical and statistical methods. Okay. Now, in this, we have the first unit as roots of equation. And simultaneous linear equation. Okay, so we'll be starting our first chapter, roots of equation. Equation. Okay, so how to find the roots of equation? In 9th or 10th standard, you might have solved quadratic equation like x square minus, or let us say plus 4x plus 4 is equal to 0. This kind of equation you might have solved, right? So how did you solve this? You factorize this, right? So you converted 4x into 2x plus 2x plus 4, and then you took common as x from these two terms and 2 from here, right? So here we will have x plus 2. Here we will have 2 as common. Then here it is x plus 2 is equal to 0. Okay, now we will have x plus 2 common here from both the terms. So here we have x plus 2 and common term is x plus 2. Okay, so then we will have either x plus 2 is equal to 0 or x plus 2 equal to 0, right? So from this, we have taking 2 on this side, we have x is equal to minus 2 or x is equal to minus 2. So we found the root of the equation as x equal to minus 2. So what is this actually the root of the equation? What is the root of the equation? So whatever value makes, let us say, any ax square plus bx plus c is equal to 0. Whatever the value of x makes this total value as 0, right? That is the root of the equation. Now let us consider any function f of x. Let us say this is function f of x. Okay. Now wherever it touches to x-axis, let us say this is x-axis, this is y-axis. Okay. Now this function or this graph touches x-axis at this point, right? So this value will be root of the equation. Wherever it touches the x-axis or wherever the y value is 0, on x-axis it is 0, right? So wherever it touches x-axis, that is the root of the equation. The values of x which makes the f of x 0, that is the root of the equation. Okay. So for quadratic equation, you can easily find the root of the equation. You have 2-3 methods, and by that methods you can easily solve. For cubic also you can solve, but there might be some of the equations, like let us say we have one equation as x square minus e to the power x cos x is equal to 0. Now you cannot find easily the root of the equation for this kind of function, right? So for these kind of functions, we will be using numerical method. Okay. So we have two different kind of methods. First is bracketing method. Okay. Bracketing methods. And second are Newton-Raphson method. Newton-Raphson method. Okay. Now we will see what are the bracketing methods. Okay. Bracketing methods. Okay. In that, we have first method as bisection. Method. Bisection method. Okay. So what is this method? Let us consider one function f of x. Okay. Let us say y is equal to f of any function f of x. Okay. On plot or on a graph, we have, let us say this is f of x. Okay. Y is equal to f of x. Now we know that this function has root at this point, right? But we want to find it by calculations, right? So in this method, what we will be doing, we will have initial guess, like we will be taking two initial guesses as x1 is equal to something and x2 equal to one value. Okay. So what we are assuming, let us say this is x1 and this is x2. Okay, so what we are assuming that root of the equation lies at the midpoint of these two initial guesses. Meaning of it is, let us say x3 is the mean of these two values. Okay, so what will be the mean? X1 plus x2 divided by 2. So what we are saying that the root of the equation is mean of these initial guesses. Okay, so what, let us say the x3 lies here. Okay, mean is at this point x3. Okay, we have taken mean of x1 and x2, that is x3. We are saying that this is the root of the equation. But if we take this graph, let us say same function f of x, but in the initial cases we actually took these two values, let us say x1 and x2. Okay, now our mid value will be lying at in between this, right? So here it is x3, but our actual value or actual root is here, and whatever we have calculated, it is here. So this is not right. We are not going towards the solution of the equation or the root of the equation, right? So what is the condition that our initial guesses are right? We will see that. Okay. So if we consider this function with example, it will be more clear. Okay. Let us say this is x1 and the value of function for x1 will be y1 equal to f of x1. Okay, and for x2 the value of the function will be y2 equal to f of x2. So if y1 is y1, let us say here we will have y as positive on upper side, right? On this side, and here the y will be negative, right? So for the initial cases, if one y value is negative and another y value is positive, then our initial cases are right. If our initial cases gives y values or the symbols of y values are same, let us say we have y1 here on positive side and y2 also on positive side, so that initial guesses are not correct. So our condition is both y1 and y2 should not be of same sign. That is, one should be negative, other should be positive. If both of them are negative, then initial guesses are wrong. or both of them are positive, then our initial guesses are wrong. One should be positive, whatever, like y2 is positive, y1 is negative, or y1 is positive, y2 is negative, whatever it is. But this sign should be different for both of them, right? So this, now we will calculate. Okay, now we have calculated, say, x3, okay, as x1 plus x2 divided by 2. For this, we will calculate y3. We will put value of x3 in the function. So f of x3. Okay. Now let us say we have, in first case, we have, for the first case, we have y1, y1 is positive, y2 is negative. Okay. And our y3 is, now we have calculated it and it is positive. With example, it will be more clear. Here I am trying to explain the method. Now y3 is positive, okay? Now for the next iteration, we want y1 and y2 such that both of them are of opposite sign, right? So here we have positive, here the positive, negative. So if it is newer value is positive, then we will replace original positive value. So now new y1 is new positive, right? y3. So new x3 is, sorry, new x1 is x3 and x2 will be same. Okay. Now we have again x7 and x2. So from this we will calculate new x3 as x1 plus x2 divided by 2. Okay, and we'll do it until our solution is reached. So let us take one example. With the example, it will be more clear. We want to find the root of the equation. F of x is equal to cos x minus 1.3 x. Okay, and initial guesses are x1 is equal to 0 and x2 equal to 1. You should remember one thing: whenever we have trigonometric function, then we have to put all the values in radian. Okay, we should not put the value of x in degree, because here it is cos x minus 1.3x. Here we will be simply putting 0 or 1, and here we have cos x. We know the values of cos 30, cos 45, similar to this. So here we should put x value in radian. Whenever we are calculating, you should remember that we have to convert the calculator mode in radian. So we have x1 is equal to 0, x2 is equal to 1. Let us start with the step 1. Let us check whether our initial guesses are right. Okay, and for that, what should be the condition? Let us calculate y1 y1 is equal to f of x1 x1. So put what is our function? Cos x minus 1.3 x. So put x1 equal to 0 in this function, right? So what will be the value? Cos of 0 minus 1.3 into 0. Okay. So here we will get 1.3 into 0 is equal to 0 and cos 0 is equal to 1. So y1 is equal to 1. Now let us calculate y2. y2 is equal to f of x2. Put x2 is equal to 1 in this function. Okay. Cos 1 minus 1.3 into 1 is equal to cos 1 is 0.54. Remember, when you are calculating cos 1 from calculator, it should be in radian, right? Cos 1 is equal to 0.54 minus 1.3 is equal to minus 0.76 minus 0.76. Now we have positive value. Y1 is positive, y2 is negative, right? So our condition is satisfied. What is our condition? That the sign of the y1 and y2 should not be same, right? So our initial cases are right. Okay, so now we will calculate y3 x3. So step 2, step 2, we have to calculate the mid value. So x3 is equal to, what is x3? x1 plus x2 divided by 2. Okay. What is x1? x1 is 0. x2 is 1 divided by 2 is equal to 0 plus 1, 1 divided by 2 is equal to 0.5. So we have x3 is equal to 0.5. Now let us calculate y3 value. For this x3, what is y3? y3 is equal to, put x3 in f of x. Okay. So what is cos x3 minus 1.3 into x3 is equal to, put the value of x3 as 0.5, cos 0.5 minus 1.3 into 0.5. So Now just calculate what is cos of 0.5. Cos of 0.5 is equal to cos of 0.5 minus 1.3 into 0.5 is equal to minus 0.00153. What is this? This is negative, right? We have got y3 negative. Now we have to replace earlier negative, right? From y1 and y2, we have to replace negative. Whatever is negative, that we have to replace, because we have got y3 as negative. So which value is negative? Y2 is negative, right? So our new y2 will become our y3. So what we will do? Our x1 will be same as that of earlier. So x1 will be whatever earlier it was 0. Now we want to replace x2 with x3. Okay, and what is x3? That is 0.5. So just this value is not just this value is not minus 0.00153. Just sorry. This is equal to this value is equal to 0.22 0.2275 0.2275. Now this is positive, right? So we have to replace earlier positive. What is earlier positive? That is y1. Y1 was positive. So we want to replace y1 with new y3. So x1 will be new x3. In each iteration, just remember one thing. In each iteration, we should have one positive and one negative. That is the condition, right? So here we got y3 as positive. So in the next iteration, whatever earlier value of positive, that we will neglect. So earlier was y1 was positive. So in the next iteration, we will not take this y1 value or x1 value, and we will take the x3 as x1 and y3 as y1. So new x1 is x3 is equal to 0.5 and x2 will be same. So that is 1 and y1 will be new y2, y3, that is equal to, yes sir, that is equal to, what is y3 value? That is 0.2275. 2275, and we have y2, that is minus 0.76. Okay, so this is our step 3. In step 3, we have just replaced earlier values with new value. And based on work condition, one should be positive, one should be negative. Whatever earlier positive, that we have replaced, right? In step 4, we will check the accuracy. What is the accuracy? The difference between x1 minus x2. That is our accuracy. What is that? 0.5 minus 1 is equal to 0.5. Now, we will be given one condition that in our solution, accuracy should be less than something like 0.1 or 0.01 or something like that. So until we get the accuracy of 0.1, we will be doing the same iterations. Okay. Now we have x1, x2 as new x1 and x2 as 0.5 and 1. So we can do the same calculations, right? So we have next iteration, iteration 2. Iteration 2. In this iteration, let us say we have step 1. What should be our step 1? What we did in step 1? We calculated what we calculated y1, y2. We have y1 and y2. Now we want to calculate x3, right? We will start from step 2 because we already have y1 and y2. So we'll start from step 2. We have to calculate new x3. What is the new x3? x3 should be x1 plus x2 divided by 2. So that will be 0.5 plus what is x1? x2? 1 divided by 2. So 0.5 plus 1 divided by 2 is equal to 0.75. Okay, we got x3. Now calculate y3. y3 is equal to, put value of x3 in function f of x of x3 is equal to cos of, what is our function? Cos of x minus 1.3 x, right? So cos of x3 minus 1.3 into x3, right? So what is the value of x3? Put in this function, cos 0.75 minus 1.3 into 0.75. Okay, so calculating this, we will have y3 as cos 0.75. Remember one thing, again I am repeating, whenever you are putting this cos 0.75, ensure that you are operating in radian mode, okay, in calculator. Okay, so we have y3 as minus 0.2433, right? So this is negative. We have got y3 as negative, right? So what we will be doing? Whatever earlier was negative, that we will replace. In earlier, what was negative? Here, y2 was negative. So our new y2 will be this y3, right? And new x2 will be this x3. You have got it, right? So now it must be more clear that in each iteration, we want one positive value, one negative value. Okay. Now, in step 3, we will replace step 3. We want to replace. So, what we have to replace? y2, because we have negative value. So, there should be one negative, one positive. We have positive as y1, negative as y2. So here we have negative. So we will be replacing y2 with new y3. So y1 will be, or x1 will be whatever x1 it was in the earlier iteration. x2 will be newer x3. So we have x1 is equal to 0.5 and x2 is equal to x3, that is 0.75. Okay, and we have y1 is equal to 0.2275, 0.2275, and y2 is equal to, y2 will be new y3 is equal to minus 0.2433. Okay, now we will again in step 4 we will check accuracy. What is the accuracy we have achieved? What is the accuracy? x1 minus x2 is equal to 0.5 minus 0.75. So that is equal to 0.25. You will observe one thing, that in earlier iteration the accuracy was 0.5. Now we have 0.25. So in next iteration it will again have the lower value. So we are going towards the solution. In the next iteration, we will know what we did in first iteration, second iteration. Now we will be repeating the same steps for the next iteration, right? So in next iteration 3, we will be calculating new x3 value. Okay, x3 is equal to x1 plus x3 divided by, sorry, x1 plus x2 divided by 2 is equal to, what is x1? 0.5 plus what is x2? 0.75 divided by 2 is equal to 0.5 plus 0.75 divided by 2 is equal to, if we calculate it, it is 0.625. 625. Now, for this x3, new x3 value, we will calculate y3, right? We'll put x3 in the function cos of point 625 minus 1.3, that is our function. Cos of x minus 1.3 into x, that is our original function. We are calculating the y values by putting x values in that function, right? So 1.3 into what is x? 0.625. Now, if you calculate it, it will come as minus 0.001537. Now, this is negative, right? This y3 value is negative. Now, you can easily say, now it will be more clear. We want to replace the earlier negative value. What is the earlier negative value? That is y3. Here, y1 is positive, y3 is negative. So we will be replacing y2 and x2, right? In the next iteration. So we will be doing the same steps. Step 2, step 3, step 3, step 4, until our whatever given accuracy reach. So you can do this. I think it should be more clear with this. So you have to repeat these iterations until your accuracy is achieved, or whatever the number of iterations you have said to calculate. Okay. So do you have any doubt in this? So I will upload same lecture and you can go through it, you can revisit it.
Hello sir.
Yes.
Sir, subjectचं book मिळेल का?
Yeah. Actually, you can purchase the book, or you can take it from library as well, So you can refer C Chapra, or you can also go through local author books, whatever publication you like.
Okay sir.
Yes. Hello. Yes, Parag.
No sir, no problem.
Okay. Yeah.